Hello, my name is Mishal Gudka from CORDIO East Africa in Kenya, and I'll be presenting the Red List of Ecosystems Assessment of Coral Reefs of the Western Indian Ocean, which covers continental East and Southern Africa and adjacent island states. Coral reefs are a truly extraordinary ecosystem. They occur across the world in warm, tropical, shallow waters and provide a habitat to an extraordinary number of species, making them one of the most biodiverse ecosystems in the world. Coral reefs are an incredibly important natural asset to countries of the Western Indian Ocean and the coastal communities that live within them. They provide a range of benefits, including tourism, coastal protection, and an important nutritious food supply. Unfortunately, the many benefits that coral reefs provide the Western Indian Ocean are under threat due to numerous damaging activities and processes. This includes unsustainable coastal development, pollution, as well as climate change-induced marine heat waves. Because of the precarious state coral reefs find themselves in the Western Indian Ocean due to the numerous threatening activities, the Red List of Ecosystems provides a very important tool to be able to quantifiably assess how close coral reefs are to disappearing. Identifying ecosystems at high risk of disappearance or collapse is just one of the uses of the Red List of Ecosystems framework. In addition, the outputs can be used to track progress towards achieving environmental targets, as well as to inform the general public about the state of ecosystems. There are 5 criteria by which to assess an ecosystem using the RLE framework. Each criterion looks at a different aspect of an ecosystem and has its own set of rules which need to be applied. The final threat status of an ecosystem is the highest threat category across all assessed criteria. An important step in the RLE process is to conceptually model an ecosystem's functioning. This is done by identifying the key ecological components of your ecosystem, identifying the key drivers and pressures affecting them, and looking at the various interactions and processes between them. This initiative was a tremendous collaborative effort from researchers and institutions from across the region and abroad who contributed data. This can be seen by the long list of data contributors on the left. In addition, we held 2 workshops at the start and end of the process, attended by numerous experts. Through the numerous data contributions, we were able to build up an extensive coral reef ecological data set with data from numerous monitoring sites across the region. The data included hard coral cover, fleshy algae cover, as well as parrotfish and grouper abundance. Criterion A looks at the percentage change in geographic distribution of an ecosystem over a 50-year period. Unfortunately, mapping coral reefs is more complicated than terrestrial ecosystems like forests. Therefore, we adapted and used a proxy indicator of hard coral cover instead. Criterion B looks at the geographic distribution of an ecosystem. The premise here is that the more restricted the distribution is, the higher the risk that an ecosystem will collapse from a threatening event. 2 standardized metrics are used for this criterion: extent of occurrence and area of occupancy. Criterion C looks at the environmental degradation around coral reefs. Over the last few decades, it's become abundantly clear that thermal warming due to climate change, which leads to coral bleaching, is the major threat to the survival of coral reefs. We looked at the likely severity of this impact over the next 50 years. Criterion D looked at the biotic change in coral reefs over 50 years by considering 4 key indicators: hard coral cover, fleshy algae cover, parrotfish abundance, and group abundance. The overall results were obtained by iteratively combining the individual indicator results. The results show that the region and all ecoregions within it fall under threatened categories. The greatest threat is from future warming, and there is a lesser threat from overfishing. However, positively, the impact of past bleaching events and degradation has been masked by some level of recovery. Despite our efforts to apply the RLE framework in the most rigorous and robust manner, there are still some caveats with the method. Most of these caveats arise due to limitations in the availability of data across the spatial scale assessed, but some issues arise from inconsistencies in data collection. One of the key next steps is to build on the Red List of Ecosystems assessment and undertake detailed national coral reef assessments in 3 East African countries to identify priority areas requiring protection and feed this information into national marine spatial planning and sustainable blue economy processes. We designed the methodology so that it could easily be applied to other coral reef regions, with the hope that in the next 3 to 4 years, all coral reefs across the world would be assessed. In addition, a similar method could also be used to assess seagrasses and mangroves in the Western Indian Ocean. In order to halt and possibly even reverse declines in coral reefs, it's important to improve policy on coral reefs. One way to do this is to promote the inclusion of the RLE as an indicator to assess ecosystem area and integrity in frameworks such as the Global Biodiversity Framework of the CBD. On behalf of all the co-authors of this study, I'd like to thank you very much for your attention. I'd also like to thank the various contributors as well as NORAD who funded the study. Thank you.